Hello everyone, in today's topic, we are going to talk about exponential and logarithmic equations and inequalities. Writing logarithm to exponential form. So if we have log x to the base b equals n, it is written as x equals b to the n. And if we have log 9 to the base 3 equals 2, it is written as 9 equals 3 to the second power or 3 squared. If we have log 1 over 25 to the base 5 equals negative 2, it is written as 1 over 25 equals 5 to the negative 2. An exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, first, try writing them so that the bases are the same. If b to the x equals b to the y, as you can see here, they have the same base, then we can have x equals y. Take note, b is not equal to 0 and b is not equal to 1. And then second, take the logarithm of both sides. If a equals b, then log a equals log b, wherein a is not equal to 0 and b is not equal to 0. Now let's move on to solving exponential equations. In here, we are going to solve and later on we are going to check whether our answer is correct. So if we have 9 raised to 8 minus x equals 27 raised to x minus 3, the first thing we need to do here is to rewrite each side with the same base. So 9 and 27 are powers of 3. And then we are going to raise a power to a power. So we are going to multiply the exponents. From here, we are going to have 16 minus 2x equals 3x minus 9. Since the base are the same, we can equate the exponents. And then we are going to solve for x. Of course, we are going to transpose, then solve for x. So x equals 5. To check whether our answer is correct, we are going to substitute 5. So since 9 to the third is equal to 27 to the second power, which is equal to 729, then x equals 5 is the solution. Now let us have another one. 4 raised to x minus 1 equals 5. In here, since 5 is not a power of 4, so we take the log of both sides. And from here, we are going to apply the power property of logarithms. And then, we are going to divide both sides by log 4. And then, we are going to transpose minus 1 to the other side, so it will become positive 1. So, in the calculator, 1 plus log 5 divided by log 4 is approximately equal to 2.161. So therefore, the solution is x approximately equal to 2.161. Now let us have another one. 3 raised to 2x equals 27. In here, we are going to rewrite each side with the same base. 3 and 27 are powers of 3. And then since they have the same base already, we are going to equate the exponents. So 2x equals 3. And then, solving for x equals 3 over 2 or 1.5. Now, let us check whether our answer is correct. We are going to substitute 1.5 to the original equation. So, since 3 to the third is really equal to 27, then the solution is x equals 1.5. Now, let us have another one. 7 raised to negative x equals 21. Since 21 is not a power of 7, so take the log of both sides and then apply the power property of logarithms. And then we are going to divide both sides by log 7. So since we have a negative x, we are going to multiply each sides or both sides of the equation by negative 1. So therefore, we have x equals negative log 21 over log 7, which is approximately equal to negative 1.565. So let us have another one. 2 to the 3x equals 15. Since 15 is not a power of 2, so take the log of both sides. Then apply the power property of logarithms. Then we are going to divide both sides by log 2. And then to further solve for x, we are going to divide both sides by 3. So we will be getting x approximately equal to 1.302. So let us have a biology application. Suppose a bacteria culture doubles in size every hour. How many hours will it take for the number of bacteria to exceed 1 million? So from the word exceed, it is greater than 1 million. So at hour 0, there is one bacterium or 2 to the 0 bacteria. At hour 1, there are 2 bacteria already or 2 to the first bacteria, and so on and so forth. So at hour n, there will be 2 to the n bacteria. So rewriting 1 million in scientific notation, it is 10 to the 6. Why I use the greater than symbol? Because it states there exceed. The word exceed means greater than. So we have the inequality 2 to the n greater than 10 to the 6. So from here, we are going to take the log of both sides. And then we are going to use the power of logarithms. And from here, log 10 to the 6 is 6. So therefore, we have n log 2 greater than 6. And then we are going to divide both sides by log 2 in order for us to solve for n. And using the calculator, so n is approximately equal to 19.94. And then we are going to round it up to the nearest whole number. So it is equal to 20. So therefore, it will take about 20 hours for the number of bacteria to exceed 1 million. Let us check whether our answer is correct. So in 20 hours, there will be 2 to the 20 bacteria. If 2 to the 20 is greater than 1 million, then our answer is correct. So evaluating 2 to the 20, it is equal to 1,048,576. So therefore, our answer is correct. Let's move on to logarithmic equation. A logarithmic equation is an equation with a logarithmic expression that contains a variable. You can solve logarithmic equations by using the properties of logarithms. If log x to the base b is equal to log y to the base b, then x equals y. When b is greater than 0 and b is not equal to 1, we have the following properties. Log 1 to the base b equals 0. Log b to the base 1 over b equals negative 1. Log b to the x to the base b equals x. Log b to the base b is equal to 1. Log 1b to the base b equals negative 1. And b raised to log x to the base b equals x. Remember that x is greater than 0. Now let's move on to the different rules in logarithmic equations. So the first one is the product rule. It states that if you have log mn to the base b, it is equal to log m to the base b plus log n to the base b. So if we are going to have the product, it is equal to the sum of two logarithms. So example for this one, we have log xy to the base b. It is equal to log x to the base b plus log y to the base b. Then if we have log 6, if we are going to expand it, it is equal to log 2 plus log 3. Why? Because 2 times 3 is equal to 6. And then if we have log 9b to the base 3, when we expand it, it is equal to log 9 to the base 3 plus log b to the base 3. Now let's move on to the quotient rule. The quotient rule states that log m divided by n to the base b is equal to log m to the base b minus log n to the base b. So example for this one, if we have log x over y to the base 5, it is equal to log x to the base 5 minus log y to the base 5. And if we have log a over 5 to the base 2, it is equal to log a to the base 2 minus log 5 to the base 2. And another one, if we have log mn over 5 to the base 2, it is equal to log m to the base 2 plus log n to the base 2 minus log p to the base 2. Now, let's move on to the power rule. The power rule states that log m to the x to the base b equals x log m to the base b. So in here, if you have the exponent, it will be the multiplier. So log b squared to the base 5 equals 2 log b to the base 5. And if we have log 5 to the x power to the base 2, it is equal to x log 5 to the base 2. And then if we have log a to the third, b to the fourth to the base 7, it is equal to 3 log a to the base 7 plus 4 log b to the base 7. Now let us solve logarithmic equations. So if we have log 2x minus 1 to the base 6 equals negative 1, let us use 6 as the base for both sides. And then use the inverse properties to remove 6 to the log base 6. And from here, we are going to solve for x. So x equals 7 over 12. Now let us have another one. Log 100 to the base 4 minus log x plus 1 to the base 4 equals 1. So in here, we are going to write as a quotient. And then, we are going to use 4 as the base for both sides. Then use inverse properties on the left side. So we are going to have 100 over x plus 1 equals 4. And then solving for x equals 24. Now let us have another one. Log x to the fourth to the base 5 equals 8. So use the power property of logarithms and then divide both sides by 4 to isolate log x to the base 5. And from here, we are going to rewrite it in exponential form. So x equals 5 to the second. So x equals 25 because 5 squared or 5 to the second, it is equal to 25. Now let us have another one. Log x to the base 12 plus log x plus 1 to the base 12 equals 1. From here, we are going to use the product property of logarithms. And then, we are going to have the exponential form using the inverse properties. So we are going to have x times x plus 1 equals 12. And then solving for x, we are going to have x squared plus x minus 12 equals 0. And then we factor it out and then equate it to 0. So x equals 3 and x equals negative 4. To check whether our answer is correct, so we are going to substitute it in the original equation using 3 and negative 4. As you can see here, for x equals negative 4, it is undefined. So we call this one as an extraneous solution. So the correct solution for this one is x equals 3. So let us have another one. So 3 equals log 8 plus 3 log x. In here, we are going to have the power property of logarithms. So 3 log x will be equal to log x to the third. And from here, we are going to use the product property of logarithms. And then use 10 as the base for both sides. And then we are going to use inverse properties on the right side. So 10 to the third is equal to 1,000. And 10 raised to log 8x to the third is equal to 8x to the third. So simplifying further, it is equal to 125 equals x to the third. So the cube root of 125 is equal to 5. So let us have the last example. 2 log x minus log 4 equals 0. So first, we are going to write it as a quotient. And then we are going to use 10 as the base for both sides. Then we are going to use inverse properties on the left side. And then we are going to solve for x. Solving for x, x equals 2. So that's it for now. Thank you for watching. See you again next time. Bye.